Shafiqah. So today we're going to talk about our mechatronic project. The main objective of this project is to develop a material handling system using various actuation system and also sensor. Okay. This system consists of motor, conveyor belt, valve, pneumatic and actuating system. And we also use the Raspberry Pi to give command to all the device. Okay. Raspberry Pi is a credit card size computer which is usually used for an education purpose. Although it is slower than modern laptop or desktop, but it is a complete Linux program computer. We give command to control the way the balls being dropped into the container. This system is designed to collect altogether 8 ping-pong balls that fall in the container through moving on a conveyor belt. Raspberry Pi allows us to design, create and also execute multiple tasks which is similar to industrial operations such as material handling system.
This board is made of from cardboard and plus it's transparent and metal plate. The length from the box is 16 cm, per weight 12 cm and the height is 30 cm. Okay, this board consists a drawer that can we store the ball inside here, and the sensor can detect the metal plate that we stick here, the upper of the box.
This is conveyor belt, and this conveyor system is common piece in a mechanical handling to move an object from one position to another position. And this is the proximity sensor, and it's a device which detects or measures a physical property and indicates to respond it. It also sends a nearby object without any physical contact. A proximity sensor often emits an electromagnetic field and it looks for changes of a field for a return. For example, if you place an object over here, it sends the object and it waits for the return signal, and if it detects the return signal and it directs the signal to the Raspberry Pi. And secondly, I'm going to talk about this valve solenoid. And this is single acting valve solenoid, and this is double acting valve solenoid. Valve solenoid is an electromechanically operated valve that used solenoid. The valve is controlled by an electric current through a solenoid. Valve solenoid is used to control the flow of fluid, whether to open or close. In this experiment, we are using 3 double-acting valve solenoid, which is this one, and another 2 double-acting valve solenoid is at bottom, and another one more is single-acting valve solenoid, which is total 4 valve solenoid. Now we are going to talk about relay. Relay or starter solenoid is a part of automobile which switches a large electric current to start motor in response to a small control current, and which in turn sets the motor in motion. Therefore, in this experiment, relay acts as a switch for small circuit to control high current circuit. Now we are going to talk about the pneumatic cylinder. Here we have 4 pneumatic cylinders. Pneumatic cylinder is a mechanical device which uses the power of compressed gas to produce a force in a reciprocating linear motion that will move forward and backward a piston. There are 2 types of pneumatic cylinder are used in this experiment. This is a single acting pneumatic cylinder, and this and the bottom one and at the left bottom is the double acting pneumatic cylinder. This is PLC, programmable logic control. The most basic function of PLC is to receive input from status component, which can be a sensor or switches. When an input activated, some output will also be activated by whatever the machine is told to do. But for this experiment, we will be using PLC to obtain enough voltage for other components such as sensor, pulse solenoid and conveyor belt. To complete this project, in addition, we use such components like connecting wire and male to female wire. This male to female wire we use specially to connect Raspberry Pi to other circuit, and also we use keyboard, mouse and monitor. Finally, this is Raspberry Pi. Raspberry Pi is a low-cost credit card size computer that plugs into a monitor and uses standard keyboard and mouse. It is capable little computer which can be used in electronic project. And for our project, we use this device to run a programming called Python 3. This coding will read input sensor and act as output that moves the conveyor belt, pneumatic valve and piston.
Now we're going to talk about wiring of our system and coding of our system. In our system, we are using two input, which are proximity sensors, and then 6 output. 4 of them are solenoid valve. It required for each pneumatic cylinder to operate. And we are using another 2 outputs for the relay. AC power supply is connected to the PLC. Now PLC is converting AC power supply to DC power supply. The whole system is working in DC power supply. Now we're going to talk about relay. Each relay consists of 2 wires. One is live wire, which will be connected to the live source of PLC 24 volt. Another one is black wire, which will be connected to the interface circuit, this wire, and then it will branch out. Another wire will be branching out to the Raspberry Pi based on our GPIO. Blue wire plays a role of receiving signal from Raspberry Pi. This is proximity sensor. Proximity sensor consists of 3 wires. First wire is red wire, which is live wire, will be connected to 24 volt. And then the blue wire is neutral wire, which will be connected to the ground. And then the black wire is ground wire. Ground wire plays a main role in this proximity sensor, which is it sends signal. One is a black wire. We made a voltage divider with 2 resistors. One is 10 kilo ohm, another one is 2.2 kilo ohm, and one wire from the voltage divider will connected to the Raspberry Pi, and another one will connected to the ground. We did voltage dividers so that there is no excess voltage will be transferred to the Raspberry Pi, and it will ensure that the Raspberry Pi won't burn easily. This is solenoid. Solenoid consists of 2 wires, which are red and black wire. Red wire is live wire. Live wire will be connected to the power source 24 volt, and then the black wire will be connected to interface circuit. Black wire plays a major role of receiving signals from our Raspberry Pi. Okay, 2 ports of this interface circuit are in pair, whereby we will be connecting our GPIO at the first port and followed by our solenoid black wire to the second port. Okay, this is a Raspberry Pi. Here we can see the GPIO pins. Via the GPIO pins, we will get the GPIO outputs to the interface circuit. Okay. The last 2 port of the interface circuit is ground port. One will be connected to the PLC ground, another one will be connected to Raspberry Pi ground. Now I'm going to explain about the Python coding for material handling system. For the first line, import RPI.gpio as GPIO. The code is needed for GPIO control. Second line is import time is the code needed for split function. And then the third line, import SYS, the code needed to provide access for some variables. Next, we're going to declare the outputs and inputs. In our system, we use 6 output and 2 input. 6 output are 4 solenoid valve and 2 relay. And 2 inputs are 2 sensors. I declare that relay D using GPIO 23, relay A using GPIO 24, top right valve using 12, GPIO 12, top left valve using GPIO 60, top bottom valve using GPIO 20, top right valve using GPIO 21, right sensor using GPIO 27, left sensor using GPIO 17. This code is to ensure that the pneumatic cylinders piston are all in extended mode when we start the experiment. And these 2 codes are to ensure that the relay is turned off at the beginning of the experiment. And this one, count equal to 0, we are using count so that the process of our material handling system will end after 8 balls are dropped. Next, while count less than 4. Instead of using infinite loop, we are using loop for just 4 times to ensure that the ball will, after 8 balls drop, the system will stop. After the while count, the conveyor belt will move from right to left. If left sensor detects signal, the conveyor belt will stop immediately. After that, this is encoding for the process of the ball drop. After 2 balls are being dropped to the box, the conveyor belt will move from left to right. If right sensor detects object or metal, the conveyor belt stops, and then the process to ball drop will begin. After the 2 ball drop, the conveyor belt started to move on left. The entire loop only worked for 4 times. After the 4th time, the conveyor belt will stop. Raspberry Pi won't be receiving any signals from the sensors, and Raspberry Pi won't be giving out any signal for the solenoids and relay.
know about the challenge during making of this project. First, Raspberry Pi burned due to the wrong connection into the Raspberry Pi. Second, the sensor does not detect the metal plate. So, we adjust this metal plate higher than the first try.
Now,
Then, the pressure supply. The pressure supply insufficient to support pneumatic valve.
So now I'm going to talk about the safety and precaution. The first thing is you need to follow all the instructions properly while handling the Raspberry Pi. This is because wrong connection or plugging to the Raspberry Pi may cause it to be burned. Second, you need to make sure there is always someone beside or nearby you watching whatever you are doing, because he or she can assist you if anything went wrong. Third, you need to make sure all the food or drinks are away from you when you are dealing or doing the project. The fourth one, you need to remove all your accessories such as jewelry, chain, watches, rings, or anything else when you are conducting the project.
We have learned about programmable logic control, devices wiring, and Raspberry Pi. We have better understanding of this working principle of these three components and the method of working of these three elements together. These three elements or tool is very important for a university student to practice and examine how the automation system actually works. In our project, the sensors are used to trigger the top cylinder and the timer using Python coding with the help of vital little device called Raspberry Pi. Once the programming started, the conveyor belt will move and the box or container will hit the sensor. Then the sensor will activate the system where the on top cylinder will open and followed by the bottom cylinder and the ping pong ball will drop. It repeated on the other sensor and continue for one more cycle. We was able to complete this process using peripheral devices such as actuators and sensors. Finally, we have learned deep enough on electric circuit to supply enough voltage and current. We have also used voltage divider method in this program in order to avoid damaging on our Raspberry Pi. We also gain knowledge regarding the connection of Raspberry Pi to the output and inputs. Still, a multifunction operation of dropping ping pong ball from feeders can be designed so as to increase the functionality and productivity of the operation. Thank you.